And we begin with the root of tree. So in the fourth stage, we talk about which country the bags are made in. So either the bags are made in Korea, so this is K. K stands for the bags are made in Korea. Or the bags are made in Korea. So made in P. And the probability that the bags are made in Korea is equal to 0.6. The bags are made in Korea is equal to 0.4. Now let's look at the second stage. And in this stage, we talk about the defects of the bags. So if the bags are from Korea and the bags are defective, then we know this conditional probability of D given that K, P of D given that K is equal to 0.04. So we label this branch by this conditional probability 0.04. And if bags are from Korea, then the conditional probability of event the bags are defect free, the D prime, this is equal to 0.96. That is 1 minus the 0.04. So this guy is equal to 0.96. Now, if the bags are made in Korea, we also have defective bags and the defect-free bags. Right? Let's go back to the last page. So P of D, given P, the conditional probability that the bags are defective, given that the bags are made in Korea, is equal to 0.05. So the P of D given P, 0.05. Then the P of D prime given P, that is equal to 1 minus the 0.05. So this is equal to 0.95. Then in this way, we get the tree diagram. So this is part A. Now we will use this tree diagram to find all those probabilities in part B, C, and D. Let's go to the part B. Part B uses a tree diagram to find the probability that a bag is defective and came from Korea. In this part B, we need to find the probability of event that a bag is defective and the bag is from Korea. So this is the non-conditional probability of D intersection K. And this by product rule is equal to P of K times P of D given K. Now to check this tree diagram, P of K 0.6. P of D given K 0.04. So this is equal to 0.024. So actually, we just multiply these two probabilities on this name. Okay, we call a sequence of branches which starts at the root of the tree diagram a name. So we multiply the two probabilities on this name, then we get 0.6 times the 0.04, and this is equal to 0.024. Okay, so part B find the probability of a bag is defective and the bag is from Korea. Now let's look at the part C. Use the tree diagram to find the probability that a bag is defective. So part C, we need to find the P of D. A bag is defective. So to find the probability of the event in the second stage, you may just check all those names, okay, all those names to see which name contains this event. So this guy from here to here, this contains D. And this guy from here to here, this contains D. Then to find the probability of D in the second stage, you may follow each name and then multiply all those probabilities. So right now, we multiply the probability in this second name, then we get 0.4 times the 0.05. Then you just add, okay, from this name to name, you just add these two products. Then you get the probability of this event in the second stage. So that is equal to 0.6 and times 0.04, and then plus 0.4 times 0.05. Then you simplify, you get 0.024 plus 0.02, and finally you get the 0.044. So this is the non-conditional probability of the event that a bag is defective. And this is an event in the second stage. So for the probability of the event in the second stage, we just check those names containing this event. And along each name, we multiply, and across names, we add. So we add these two products, then we get the probability of D. Now part D, find the probability that a bag is defect-free. So this is the D prime. So actually, you may use the one rule, 1 minus the P of D. And then this is equal to 1 minus 0.044, and this is equal to 0.956. Actually, you may also check those names containing this D prime. So now you see this guy contains D prime, and this guy contains D prime. And then along each name containing D prime, you multiply 0.6 times 0.96. And here you have the 0.4 times 0.95. Then across names, you add. You add these two products, you have the 0.6 times the 0.96 and plus 0.4 and times 0.95. You simplify, you should get the same answer. But this fourth way is simpler because we may just directly use the result from part C. Any question?